Hello to everyone. In this video, let us discuss what here Lechatelier principle and what are the applications and questions regarding which one Lechatelier principle. So first, what is the statement here means? It is related to which one equilibrium reactions. So now, according to Lechatelier principle, we have to determine what are the conditions required for the more yield of the desired product. So like that, what is the statement here? So if a reaction present at equilibrium subjected to change in its concentration or pressure or temperature, now the equilibrium shifts in the direction to neutralize the change. I repeat again. If any reaction present at equilibrium, a reversible reaction present at equilibrium, when subjected to change in concentration or pressure or temperature, now the equilibrium shifts in the direction to neutralize or to nullify the change. So that is the statement of which one? Lechatelier principle. Now in that, let us discuss first effect of concentration. So let us discuss which one here? Effect of concentration. So what is this effect here? Consider a reversible reaction. Reactants gives products. Now, by increasing the concentration of reactants or by decreasing the concentration of products, forward reaction takes place vigorously. And by increasing the product concentration or by decreasing the reactant concentration, backward reaction takes place vigorously. This we can explain with a simple example here. Let it be the two vessels A and B having same volume. These two are connected at the bottom with a pipeline. Now, in this, for example, same level of water is there. Same level of water. Now, A to B, B to A, there is a same flow of water, means that is present at equilibrium. But if we add some extra water in A, or if we remove some water from B, what happens now? There is a water flow takes place from A to B. So same in this case also. By increasing the reactant concentration, that means by pouring water in A. Otherwise, by decreasing the product concentration, that means by removing some water from B vessel. Now what happens? Forward reaction takes place vigorously. Now, in controversial to that, if by increasing the product concentration, that means by adding some extra water in B, now what happens? Water flows from B to A. Otherwise, if we remove some water from A, at that time also B to A water will flow. So like that, by increasing the product concentration or by decreasing the reactant concentration, backward reaction takes place vigorously. So this is effect of which one here? Concentration. This is effect of concentration. Okay, then next one is here effect of pressure. What is the second one means here? Effect of pressure. So what is the effect of pressure on equilibrium? Let us see here. So for example, if you consider 2A gives B. So here two reactants are there, means here high pressure is present. Here only one product is there, means low pressure is present. So in reactant side high pressure, in product side low pressure is there. So for example, if we exert the high pressure on this equilibrium, as per Lechatelier principle, the equilibrium moves towards low pressure side. that means less number of moles side. So by increasing the pressure, equilibrium shifts towards less pressure side, that means less number of moles side. Otherwise, if we increase the, that means if we decrease the pressure, if we decrease the pressure, equilibrium shifts towards more pressure side, that means high pressure side, that means more number of moles side. So I repeat again that by increasing the pressure, equilibrium shifts towards less number of moles side. By decreasing the pressure, equilibrium shifts towards more number of moles side. So this is which one means effect of pressure. Okay, then after that, effect of temperature. So let us see what is the effect of temperature. So to know that effect of temperature, let us know about exothermic and endothermic reactions. So if in a reaction energy is liberated, that is said to be exothermic reaction. And in a reaction if some heat energy is absorbed, that is said to be endothermic reaction. Now, as per Lechatelier principle, low temperature is favorable for exothermic reactions and high temperature is favorable for endothermic reactions. So these are the factors affecting which one? Equilibrium. And now let us go for applications of Lechatelier principle. So what are the applications here? First one, preparation of ammonia in Haber's method, means N2 gas plus 3H2 gas gives 2NH3 gas. Here delta H minus means this is minus 92 kilojoules. That means it is exothermic reaction. First, effect of concentration. So if you want to get more yield of ammonia, what we have to do? Either by increasing N2 and H2 concentration or by decreasing NH3 concentration, forward reaction takes place vigorously, then we can get more yield of ammonia. So that is effect of concentration. Now come to effect of pressure. So we have to see effect of pressure. So what is our intention here? To get more yield of ammonia. To get more yield of ammonia means forward reaction should take place vigorously. So now see here, in reactant side 4 reactants are there, means high pressure. In product side only 2 products are there, so low pressure. So forward reaction means towards low pressure the reaction should occur as per our intention. But according to Lechatelier principle, which pressure favors that reaction towards low pressure side? High pressure favors. So if you apply high pressure on this equilibrium shifts towards low pressure side. That means towards forward reaction towards ammonia. So for this reaction, which pressure is favorable means high pressure is favorable. For that reason, we use 200 atmosphere pressure for the more yield of ammonia. And let us see effect of temperature. So as it is exothermic reaction, which temperature favorable means low temperature is favorable. But to enhance the speed of the reaction, we use 725 to 775 Kelvin temperature for the more yield of NH3. And also to increase the yield of ammonia, we can use that iron rupture, that means finely divided iron as a catalyst and molybdenum as a promoter. So this is one of the applications of which one? Lechatelier principle. Now come to the second equation. What is that? Preparation of sulfuric acid by contact method. In that one important equation is 2SO2 plus O2 gives 2SO3 delta H. This is also minus 189 kilojoule per mole. This is also exothermic reaction. So now here, first effect of concentration. Our intention is to get more yield of SO3. So we have to look for forward reaction. Now to increase the rate of forward reaction, what we have to do? We have to increase the concentration of SO2 and O2, and also we have to decrease the concentration of SO3. Therefore forward reaction takes place vigorously. And now let us see effect of pressure. So here 2 plus 1, 3 moles of reactants are there, and here only 2 moles of products. 2 moles of products means low pressure. Here 3 moles means high pressure. That means as per our intention, the reaction should, the equilibrium should move towards low pressure side. As per Lechatelier principle, high pressure favors the reaction to move towards low pressure side. So that's why for this equilibrium, which pressure is favorable means high pressure. But a small condition here. What is that? A small change. What is that? At high pressure, this SO3 will eats away the vessel surface, because SO3 is having acidic nature. At high pressure, that leads to corrosion of that vessel. Due to that, holes may be formed and SO3 may be escape outside. So for that reason, we have to use moderate pressures. How much means here? 1.5 to 1.7 atmosphere pressure is used for the preparation of SO3. Actually high pressure favorable, but a small change due to acidic nature of SO3. Now let us see effect of temperature. As it is an exothermic reaction, low temperature is favorable. But to enhance the rate of reaction, a moderate temperature, 673 Kelvin, is used for more yield of SO3. Now, after these applications, let us see what are the different type of questions we see from this topic. So first question I give here, A plus B gives C plus 100 kilojoule. The question is here, to get the more yield of C, what are the conditions favorable? That means with respect to temperature and pressure. Which temperature, which pressure favorable for the more yield of C? That means here forward reaction should take place vigorously. In that way we have to think. So now see, in forward reaction, let us see pressure effects. Here two reactants, here only one product. That means in forward reaction, pressure decreases. Here low pressure, here high pressure. So in forward reaction, pressure decreases. That means which pressure we have to use? For that means high pressure. So for the more yield of C, which pressure is favorable means high pressure. And let us see effect of temperature. As formation of C is an exothermic reaction, so more yield of C is possible by using low temperature. Now the same question they may give in another way. What are the favorable conditions for the formation of A and B if they have given? Means we have to reverse those previous conditions. Means we have to use low pressure, and as if forward reaction is exothermic means backward reaction become endothermic. Endothermic means we have to use high temperature. For which one? Backward reaction. Okay, now another question is there. What is that important one here? Addition of inert gas. Addition of inert gas to that equilibrium. In that two conditions are there. Addition of inert gas, first condition at constant volume, and second condition at constant pressure. So At constant volume, if you add inert gas, there is which one here? No effect of that inert gas addition on that equilibrium. At which one means at constant volume, if we add inert gas to equilibrium, it shows no effect. But if you add inert gas at constant pressure, there is some effect. What we have to see that at constant pressure, if inert gas is added, so now what happens? If inert gas is added means volume of the reaction mixture increases, because addition of some extra inert gas into that vessel, what happens? Volume of that reaction mixture increases. And as per Charles law, we know that as volume increases, now what happens? Pressure decreases. Pressure decreases means if we are using low pressure on equilibrium, what happens? Equilibrium shifts towards more pressure side. That means equilibrium shifts towards more number of moles side. So only we have to remember one thing here. If we add inert gas at constant pressure, equilibrium shifts towards more number of moles side. This is final. We have to remember that one only. If inert gas is added at constant pressure to an equilibrium reaction, that equilibrium shifts towards more number of moles side. Let us consider this example. Now, for example, in this equilibrium, if inert gas added at constant pressure, which reaction takes place vigorously? They give the question. So, which reaction means if we add inert gas at constant pressure, that moves towards more number of mole side. More number of mole side means forward not. Which reaction takes place vigorously? Backward reaction takes place vigorously. Otherwise, if I have given this equation like 3C, now here only two reactants, here three products are there. So if inert gas added to this equilibrium shifts towards which side, which reaction takes place vigorously means forward reaction. Towards product side, the reaction takes place vigorously. So like that, final conclusion is here. If inert gas added at constant volume, there is no effect of that addition of inert gas. But if inert gas added at constant pressure, the equilibrium shifts towards more number of moles side. That is, you have to remember. Okay, then last topic in this is which one? Reaction quotient. So what is reaction quotient? Let us see here. And what are the related questions towards that one? So what is that first here? Reaction quotient. So what is reaction quotient means? QC, it is nothing but Kc only. But what is the difference? Let us see here. Products concentration by reactants concentration. So the ratio of concentration terms of products and reactants at any time of the equilibrium or at any time of the reaction is known as reaction quotient. Not only at equilibrium, either at initial state or at a final stage or at any stage of the reaction, the ratio of concentrations of products and reactants is known as reaction quotient. And what is the relation with Kc? So see here, if given Qc value is greater than Kc, which reaction takes place vigorously? They give the question. So now, if Qc value greater than Kc means in these two values, numerator is greater than denominator, because Qc value greater means this value greater means numerator should be greater than denominator. If products are more than reactants, so which reaction takes place? Backward reaction takes place. So if Qc greater than Kc, backward reaction takes place vigorously. And otherwise, if Qc less than Kc, QC less than Kc means QC value is less. When that QC value less we can get when reactants concentration more than that of products. Then what happens now? Forward reaction takes place vigorously. Forward reaction takes place vigorously. So, related to that, I will give one question here. What is that? For example, A gives to B, and for this, Kc value they have given 2, and concentrations of B and A also given. B concentration 2, A concentration also 2. Now, which reaction takes place vigorously? First, let us calculate Qc. Qc means what we have to write here? B power 2, because 2 moles here, and A power 1. So now here B power 2 means what here? 2 into 2, because B concentration have given 2, and A. So 2 ones are 2 to get cancelled. Now Kc value given is equal to Qc. That means the reaction already present at equilibrium. For suppose if Kc value given 1, then what we have to write now? Qc greater than Kc. Qc greater than Kc means which reaction takes place? Backward reaction takes place vigorously. For suppose I have given Kc value 3. Therefore, what we have to write now? Qc value less than Kc. If Qc less than Kc, which reaction takes place vigorously? Means forward reaction takes place vigorously. So like this, we have to answer such type of questions related to which one? Reaction quotient. So this is regarding which one? Lechatelier principle and reaction quotient. Okay, bye.